Okay, ladies and gentlemen, thanks for watching my video. Yesterday, we were doing this Desmos activity and um, we had this kind of situation. Let's do a right estimate, right rectangle estimate. So if we zoom in on this was slide 13. You can see that I've put all the numbers in correctly. So let me explain that a little bit. We are going from -5 over here to -1, and that's a distance of 4, right? 1, 2, 3, 4. So if they want 4 equal subintervals, that means I'm just counting by 1 each time. 1, 1, 1, 1, right? So my first interval is a little weird because there isn't even a rectangle there, right? So the width is 1, but then the right side of that interval is hitting the parabola. So there's no height at all to the rectangle. It's just a width. So that's why I've got a height of 0 and they've got an area of 0. The next one might make more sense. When we look at this interval right here from between -4 and -3, if I go to the right side of that interval, my height of my rectangle would be -3 because we're going down 3, 1, 2, 3, and the width is 1. So we got 1 for the width and -3 for the height. If I go to the right side of the interval and I go down, I'm going down 4 in this case. So it's 1 wide and -4 tall, if you will. So -4 right here. So my area is -4, right? 1 times -4. The next one, I'm going over 1. I'm going down 3, right? Well, let's relate this to that motorcycle example in our notes. And let's try to make this a little bit clear. Let's say I was going to do 4 subintervals over this 10-second time frame. And so I've done down here with the little formula to figure out what my delta x is. So it's 10 minus 0 because it's 10 minus 0, the upper limit minus the lower limit, right? And then we divide it by the number of intervals that we want. So we're getting 2.5. So I'm going to count by 2.5. So let's see if we can just break this up into 4 equal parts. So 2.5, 5, 7.5, and then 10. Now, if I wanted a right-hand rectangle, let's do right-hand approximation, a right rectangle approximation. Then what I'd want to do is I'd want to go to the right side of the interval and I would find the height at that spot. And I know this sounds weird, but look, my rectangle is going outside my curve here. And so this is going to be an over approximation, right? Now, without a function here, the best I could do would be just to, estimate. Maybe it's at 100, right? It looks like it's about halfway between 0 and 200. Let's do one more here. So if I go to the right side of the rectangle, I'm at 5 here, and I go up. If I had a function, I could plug 5 into the function, but I don't have a function. So, again, the best I could do would just be to estimate. Maybe it's at like, I don't know, 175 or something like that, right? So let's put that down. Let's say this is at 100. Let's say this is at 175. Let's go to the next one. If I go out here, oh geez, my rectangle looks a little bit bigger on this one. So what's that at? Maybe like 190. So let's say we got 190 here. Oh, and by the way, this is 2.5, right? So 2.5, 2.5, 2.5. I went to the right side of the rectangle. Let's do that one more time. Right side of the rectangle. And I go up, I go over. Man, that's probably like, she's probably doing like 198 now, let's say. So it's still 2.5 wide. So what would the area approximation be? Area is approximately equal to, right? Equals with a dot over is one way to say approximately equal to 2.5 times 100 plus, 2.5 times 175 plus 2.5 times 190 plus 2.5 times 198. 2.5 times 198. Okay. Now you see they all have 2.5 in them. So sometimes they factor out that 2.5. They put down like 2.5 times 100 plus 175 plus 190 plus 198, right? And by the way, this would be a distance that she's traveled. Now, I don't think we have to worry about the application aspect in our homework today, like what are the units and all that kind of stuff. They just show us a graph and they ask us to partition it into two subintervals and they tell us what those subintervals are, 1 to 5. Notice this is interval notation, so we're going from 1 to 5, and then from 5 to 9. Your numbers are going to be different probably. And it says approximate the area using a left-hand approximation, right? A left-hand approximation. So let's put that in our notes. Let's come down here. I'm going to take a picture of that problem, and let's see if, oh geez, it's not working. Hold on one sec here. Let me try again. I think I didn't click on the right thing. Boom, boom. Okay, so I'm going to get a picture of this problem. We'll put it into our notes and see if we can figure this baby out. Okay, so it wanted left-hand rectangles, and it wants two subintervals. So if it wants a left-hand rectangle, I'm going to go to the left side of the interval, and I'm going to figure out what the height is at that left side. I'll draw the whole rectangle in here. And they tell us, hey, look at that. The height is 3. So I'm going to put a 3 here. What's the width? I'm going 1, 2, 3, 4 over. So the area of this rectangle is going to be 3 times 4. Now we're going to add to that excuse me. Try that again. The width of the rectangle is 4. 1, 2, 3, 4, because it said equal subintervals, right? So I definitely have a width of 4. What's the height? Oh, left-hand rectangle. See my little arrows over here reminding me I'm doing a left hand. So I go up to here, which, oh, look at that. They tell us it's 4. So that's how they're giving us that information. And then I come over here, and so I've got, what, 4 times 4. So it's like I've got the height times the base, if you will. I don't know why I put those out of order. Usually it's base times height, but it doesn't matter, right? Hopefully that's okay with you. And so this is my definite integral approximation from 1 to 9, from 1 to 9. My function is called f of x. This is the way they put it in here. And then the dx is just part of the notation. Ooh, let me put a little dot over because that's my approximation for that definite integral. So what do I get? I get 12 plus 16 would be, I think, 28, right? So I put 28 right in here. Notice they're saying square units. We don't have units down here on the x-axis or the y-axis, and they are saying it's an area. So it's probably okay that they're using an area. So if I check 28, let's see. Oh, yes. Okay, good luck with this homework. I know you can do it. Thanks for watching my video. I appreciate it.